You're here because you want to get smart, fast.
Yeah.
You want the core knowledge without maybe all the extra fluff.
That's the idea.
Today, we're really zeroing in on a foundational chapter.
Sure.
Regulations, maintenance, records, and publications from a key aviation handbook. Think of this as your rapid onboarding session, kind of the essential rules that every aircraft lives by.
That's right. We've got a ton of material here that essentially forms the rule book for the skies. It covers pretty much everything from the regulations themselves to the crucial paperwork, the guides that ensure every aircraft is safe and airworthy.
Mm-hmm.
And it's not just about the here and now. Understanding how these rules have developed alongside aviation technology, it really gives you an appreciation for the whole system.
Exactly. Our goal today is to break down this chapter piece by piece, almost like we're sitting down together for a personalized briefing. We want you to come away with a really rock-solid understanding of the key ideas and how they all, fit together.
Makes sense.
So let's maybe start with an overview of what this chapter covers.
Absolutely. The chapter kicks off by looking back a bit at the history of aviation regulations, specifically from 1926 up to 1966. There's a figure, 2-1, that shows this timeline.
Okay.
What's interesting is that the regulatory framework wasn't just set in stone back then. It was a living thing, constantly adapting as aircraft technology changed. It really shows this long-term thinking within the FAA, always considering, what's next for aviation.
It really does highlight that the rules had to keep pace with how quickly planes were evolving. I mean, you just imagine the difference between those early biplanes and the jets coming in by the mid-60s. The regs had to bridge that somehow.
Precisely. And that brings us to today and Title 14 of the Code of Federal Regulations, or 14 CFR. This is where you find the current active regulations for basically everything aviation in the U.S.
Right.
There's another figure, 2-2, that shows it's not just one giant book. It's organized into 5 different volumes under the heading Aeronautics and Space.
5 volumes, okay.
Yeah. Volumes 1, 2, and 3 focus on the FAA itself, covering a huge range of regulations. Then Volume 4 shifts over to the Department of Transportation, looking at things like aviation proceedings and, interestingly, commercial space transportation. That's a growing area.
Mm-hmm.
And finally, Volume 5 deals with NASA and also keeping the air transportation system stable.
Okay, so it's a big set covering different but, related areas. And within these, the chapter groups the regulations into 3 main types.
Correct. You've got administrative rules, which are sort of about how the FAA runs itself. Then there's airworthiness certification that's all about making sure aircraft are designed and built safe from the get-go.
Like initial approval.
Exactly. And then airworthiness operation, which covers the rules for actually flying and maintaining those aircraft safely throughout their whole service life.
Now, I know a lot of folks might still use the term RRs. What's the deal with that? Is that still current?
That's a good question. Yeah, back in 1958, these regulations were commonly called FARs, Federal Aviation Regulations. But there's another whole set of government rules, Title 48, called the Federal Acquisitions Regulations, also FARs.
Oh, I see the problem.
Yeah, having 2 FARs caused a lot of confusion.
Oh.
So the FAA started pushing the 14 CFR Part XX format, like 14 CFR Part 91, just to be crystal clear and avoid those mix-ups. It's all about clarity, especially when you're dealing with aviation safety.
That makes total sense. You definitely don't want any ambiguity there. And there's that interesting little detail about how most of the regulations are numbered, right? Something about odd numbers.
Yeah, that's a fascinating bit of trivia. Most of the regulations and even the sections within them have odd numbers. This wasn't just random. It was a deliberate choice back when they converted the old civil aeronautics regulations into the FRs.
Okay. Why?
The idea was to leave gaps. So if they needed to add a new regulation later between, say, Part 23 and Part 25, they could slot in a Part 24 without having to renumber everything that came after it.
Huh. That's actually really clever, like leaving space on a bookshelf for future books.
Exactly. Regulatory foresight, you could call it.
Okay. Now let's move on to several federal aviation regulations, or SFRs. How do these fit in?
Right. SFRs are a bit different from the regular ongoing rules like Part 91 or Part 43. Think of them as temporary adjustments or special rules for specific, often unique situations.
Like what kind of situations?
Maybe a major air show needs some specific procedures, or there's a particular safety concern that needs a quick, short-term regulatory fix. Figure 2.3 gives some examples, though we don't need to list them all. The key thing is that SFRs usually have a limited lifespan, a set time period they're in effect.
So they're not permanent changes to the rule book, more like temporary patches or specific instructions for a limited time. And the numbering, does it tell you what part it affects?
No, the number is just sequential. So SFAR number 88 came after SFAR 87 and so on. It doesn't relate to the regulation part number it might be modifying or the topic. It's just a unique identifier for that temporary rule.
Got it. Okay, so after laying out this general framework, the chapter then really narrows its focus onto airworthiness certification.
That's a really crucial shift. A big chunk of this handbook, and definitely this chapter, digs deep into the regulations that govern how aircraft get designed, built, and initially approved as safe to fly.
Right, that initial stamp of approval.
Exactly. Figure 2.4 actually lists 30 of these key airworthiness certification regulations. And then figure 2.5 gives this great visual. It shows how they all connect and interact. It's like a flow chart for getting an aircraft certified.
That visual must be super helpful. It's not just a random list of rules. You can see how, like, Part 23 connects to Part 33 for the engine and so on.
Precisely. It shows the system. And at the very heart of all this talk about airworthiness is, well, a really fundamental question. What does airworthy actually mean?
You'd think that would be obvious, right?
Well, you might be surprised. The FAA only formally defined airworthy in the regulations themselves fairly recently.
Really? It wasn't officially defined before?
It was definitely implied, especially in Part 21, Section 21.183. And you'd find the concept in non-regulatory stuff, like on the standard airworthiness certificate itself, FAA Form 8100-2 in Block 5. But the official legal definition is now in 14 CFR Part 3.
Okay, so what is the official definition then?
According to Part 3, Section 3.5, an aircraft is airworthy if 1, the aircraft conforms to its type design, and 2, is in a condition for safe operation.
Ah, so 2 parts. It has to match the blueprint, basically, and be safe to fly right now.
Exactly. It's not enough just to be built right. It has to be kept right, kept safe.
That makes perfect sense. And that standard airworthiness certificate, the 8102 form, that has to be displayed in the aircraft, right? Like the registration in a car.
Absolutely. The regs required that certificate to be clearly visible on board every U.S. civil aircraft. It's kind of its initial license to operate.
Okay. The chapter then also defines a couple of related terms from that same section, Part 3, Section 3.5.
Yeah, just quickly, it clarifies that a product in this context means an aircraft engine, or an aircraft propeller.
Major components.
Right. And then it defines record really broadly. It's basically any information that's kept or passed along, paper, microfilm, ID plates, electronic files, you name it. And these records can be separate documents attached to a part or even marked directly onto a part or material.
So documentation is key, if it's not written down.
It essentially didn't happen from a regulatory standpoint. That's why record keeping is so vital in aviation.
Understood. Now, the chapter also distinguishes between different areas of airworthiness.
It does. It splits it into original airworthiness, which is all about that initial certification process we saw in Figure 2.5, getting the aircraft approved in the first place.
Okay.
And recurrent airworthiness, which Figure 2.6 illustrates, that's about maintaining that airworthiness throughout the aircraft's life, through inspections, maintenance, repairs, all that ongoing work.
Original and recurrent.
Yeah.
Got it. And you mentioned earlier that there are 3 really core regulations that a lot of this stuff ties back to.
Exactly. These are the big 3 pillars, you could say. First, 14 CFR Part 21 certification procedures for products and parts. That's how you get the type certificate, the design approval.
Okay, Part 21.
Second, 14 CFR Part 43, maintenance, preventive maintenance, rebuilding, and alterations. This is the absolute heartland for maintenance technicians. It dictates how maintenance must be done.
Part 43, the maintenance Bible.
Pretty much. And third, 14 CFR Part 91, general operating and flight rules. Now, this is mainly about how you operate the aircraft, the rules of the sky for pilots and owners.
But it affects maintenance, too.
Oh, definitely. It sets requirements for things like inspections, required equipment, and record keeping that directly impact maintenance. Those figures 2.5 and 2.6 really do a good job showing how most of the other airworthiness rules link back to these 3, 21, 43, and 91.
Okay, 21 for certification, 43 for maintenance, 91 for operations, but with maintenance links. That's a helpful framework. The chapter then quickly touches on the FAA's internal structure.
Right, just pointing out that the FAA isn't just one monolithic block. It has different subgroups with specific oversight jobs. For a maintenance tech, the main folks you'll likely interact with are in the Flight Standards Service, or AFS, specifically through your local Flight Standards District Office, the FSDO.
The FSDO, okay.
But depending on the issue, especially if it involves design changes or major repairs, you might also interact with the Aircraft Certification Service, or ARR. Knowing who does what can be helpful.
Good to know. The chapter then sort of zooms back out to give that wider view of Title 14 CFR again, reminding us about the volumes and subchapters.
Yeah, it recaps the 5 volumes and the agencies, but then it breaks down the subchapters within Title 14. It's just to show the breadth. Like, Subchapter D is for airman certification.
Pilots, mechanics, dispatchers.
Exactly. Subchapter E is airspace. F is air traffic and general operating rules. That's where Part 91 lives.
Okay.
Then you've got G for air carriers and operators, H for schools and certificated agencies like repair stations, I for airports, J for nav facilities.
K for admin regs, N for war risk insurance. It really covers everything.
It does, all the way through economic regulations, procedural rules, special regs, even FAA organization and policy statements. It just paints the picture of how comprehensive this whole regulatory system is.
It definitely does. Okay, so after that broad overview, the chapter starts diving into specific parts of 14 CFR, beginning logically with Part 1.
Makes sense. Part 1 is titled Definitions and Abbreviations. Pretty self-explanatory.
So, the official dictionary for the rest of the rules.
Basically, yes. And Section 1.2 specifically focuses on abbreviations and symbols you'll see used, especially in relation to flight operations.
Okay. Then Part 21, which we mentioned, is one of the big 3, focusing on certification.
Right. 14 CFR Part 21, Certification Procedures for Products and Articles. This lays out all the details, the requirements, the steps, the procedures for getting a type certificate for a new aircraft engine or propeller design. It's the rule book for getting a new product approved.
The starting point for any new aircraft design. Then the chapter moves to Part 23. This seems like a really significant one for a lot of aviation.
It absolutely is. 14 CFR Part 23, Airworthiness Standards, Normal, Utility, Acrobatic, and Commuter Category Airplanes. This covers the vast majority of what we think of as general aviation.
So like trainers, small private planes, even up to corporate jets.
Exactly. Everything from little 2-seat trainers right up to some pretty sophisticated corporate jets fall under Part 23. The key limits are usually 9 passengers or less, although the commuter category bumps that up to a max of 19 passengers, not counting the pilots.
Okay.
And typically it's for aircraft with a maximum certificated takeoff weight of 12,500 pounds or less, though again, the commuter category goes up to 19,000 pounds. Part 23 sets all the specific airworthiness standards a manufacturer has to meet to get that type certificate, and also for individual aircraft to get their airworthiness certificate.
And it's broken down into subparts, A through G.
Correct. 7 subparts covering everything. Subpart A is applicability, who this part applies to. B is flight, how it has to perform. C is structures, how strong it needs to be. D is design and construction, the nuts and bolts. E is power plant. F is equipment. And G is flight crew interface and other information.
Wow, okay. So what kind of specifics are we talking about within those subparts?
Oh, incredible detail. Things like the allowable center of gravity range, the load factors the wings have to withstand, standards for fasteners, how the controls must work, engine and propeller requirements, fuel tank markings, required instruments and placards, even minimum cabin aisle width for escape, and the flammability standards for cabin materials. It really gets down to the nitty-gritty to ensure safety.
That sounds incredibly thorough. So that's Part 23 for GA and commuter. What about the big airliners?
That's where Part 25 comes in. 14 CFR Part 25, Airworthiness Standards, Transport Category Airplanes. This applies to those large aircraft, typically over 12,500 pounds maximum takeoff weight. Think commercial aviation. The Boeings, the Airbuses, though it's not just passenger capacity. Large cargo planes fall under Part 25 too.
And is it structured similarly to Part 23?
Interestingly, yes. The subpart categories, flight, structure, design, and construction, etc., and even their sequence are quite similar to Part 23. But as you'd expect, the actual requirements within those subparts are generally more stringent to account for the size, complexity, and operating environment of these larger aircraft.
Makes sense. Higher standards for bigger planes carrying more people. Okay, what about helicopters?
Good question. The chapter covers rotorcraft next, starting with Part 27. 14 CFR Part 27 is Airworthiness Standards, Normal Category Rotorcraft. This is basically the Part 23 equivalent for smaller helicopters.
So similar limits.
Yep. 9 passengers or fewer, but the weight limit is lower, 7,000 pounds maximum certified weight. And again, it has similar design-focused subparts detailing the build requirements.
And for the bigger helicopters, the transport ones.
That's Part 29. 14 CFR Part 29, Airworthiness Standards, Transport Category Rotorcraft. This covers helicopters over that 7,000-pound limit. It gets a little more complex here with additional parameters based on seating 9 or less versus 10 or more, and another weight break at 20,000 pounds.
More categories within the category.
Right. But despite that added complexity, the basic structure, the design subparts, are still quite similar to what we saw in parts 23, 25, and 27. There's a consistent framework.
Okay, a common thread in how they approach airworthiness standards across different aircraft types. Now, after the airframes, the chapter talks about the things that make them go engines and propellers.
Exactly. We start with Part 33 for engines, 14 CFR Part 33, airworthiness standards, aircraft engines. This is critical because all those aircraft certification parts, 23, 25, 27, 29, they all require the engines installed to be type certificated under Part 33.
So the engine has its own approval process.
Absolutely. Part 33 details the design, the construction, and importantly, the really demanding blog test requirements. These tests push the engines hard, both piston and turbine, to prove they can reliably and safely produce power under expected operating conditions and even beyond.
Sounds intense. And propellers get their own part, too.
They do. Part 35, 14 CFR Part 35, airworthiness standards, propellers. Just like engines, propellers used on type-certificated aircraft also need their own type certificate. Part 35 mirrors Part 33 in structure, Subpart B covers design and construction, and Subpart C details the tests and inspections they have to pass.
So we've covered how aircraft, engines, and propellers get their initial approval based on these design standards. But regulations change over time, right? Does every plane flying have to meet the absolute latest rules?
That's a really crucial point the chapter makes. No, not necessarily. When regulations get revised, those changes are published in the Federal Register, and they get an amendment number so you can track the history.
Right.
But the key principle is this. An aircraft generally only needs to meet the regulations that were in effect at the time it was originally manufactured and type certificated. You don't usually have to go back and retrofit older planes to meet every single new design standard that comes out later.
Okay, that makes sense. It would be almost impossible otherwise.
Yeah.
But you said generally. Is there an exception?
Yes, and it's a big one. Airworthiness Directives, or ADs.
ADs. Okay, tell me about those.
ADs are issued under Part 39. They come about when the FAA finds an unsafe condition in an aircraft, engine, propeller, or appliance after it's already been certified, and they determine that this unsafe condition is likely to exist or develop in other products of the same type design.
So it's a safety issue found later on.
Exactly. And unlike those design standards, ADs are mandatory. They often require specific inspections or modifications to be done by a certain compliance date or within a certain number of flight hours or cycles. And these requirements supersede the original certification basis. An AD has to be complied with, regardless of when the aircraft was built.
So ADs are the mechanism to fix safety problems that emerge after certification. Where do you find the actual AD notes? Are they in Part 39?
No, Part 39 itself just sort of establishes the framework for ADs. The actual AD notes, the specific instructions, are published in the Federal Register. They're then linked as amendments to Section 39.13. But the important thing is that these AD notes are legally enforceable rules. Compliance isn't optional.
Got it. ADs U.S. mandatory safety actions.
No.
Okay, shifting gears a bit. The chapter then brings us back to one of those core regulations we mentioned earlier. Part 43, all about maintenance.
Yes. 14 CFR Part 43, maintenance, preventive maintenance, rebuilding, and alteration. This is, as we said, really the central regulation for aviation maintenance techs. It's one of the big three.
Right.
It contains 13 specific rules and 6 appendices that provide the standards for maintaining pretty much all U.S. registered civilian aircraft. And as Figure 2.6 showed, it has a really significant direct relationship with Part 91, the operating rules, and other regs that ensure continued or recurrent airworthiness. We'll definitely be digging into the specifics of Part 43 later.
Okay, looking forward to that. Next, the chapter covers Part 45, which deals with marking and identification.
Right. 14 CFR Part 45, identification and registration marking. This covers how aircraft, engines, propellers, and even certain important parts need to be identified. It also specifies the requirements for the nationality and registration markings, the N number on U.S. aircraft.
So what kind of identification are we talking about, like serial numbers?
Exactly. For type-certificated products, it requires a fireproof data plate or another approved fireproof method that shows key info. The builder's name, the model, the serial number, the type certificate number, production certificate number if applicable, the engine rating for engines, compliance with certain emission standards under Part 34 maybe, and anything else the FAA deems necessary.
Okay, that's for the main product. What about replacement parts?
Good question. If a part is a replacement or modification part made under what's called a Parts Manufacturer Approval, or PMA,
PMA, right.
it also needs specific markings. It has to show FAA, PMA, the PMA holder's name or trademark, the part number, and which type certificated products it's eligible for installation on.
So you know it's approved and what it fits.
Precisely. And there's more. Parts that have specified replacement times, inspection intervals, or related procedures must be marked with a part number and a serial number.
Life-limited parts, for example.
Yes, exactly. The manufacturer is responsible for providing instructions on how to mark these life-limited parts, or if marking them would compromise them, they have to state that. There are exceptions for really tiny parts where it's just not feasible to put all the info on them.
It's all about traceability, knowing exactly what part is what and its history or limitations. Makes sense. Then Part 47, aircraft registration.
14 CFR Part 47. This just outlines the requirements and the process for registering aircraft in the U.S., whether you're an owner or a dealer. As Figure 2.5 showed, registration ties into both original airworthiness, when it first gets certified and registered, and recurrent airworthiness, keeping the registration current. It's how the FAA tracks who owns which aircraft.
The official ownership link.
Okay.
After registration, the chapter looks at Part 65, certifying airmen other than flight crew members.
That's right. We know Part 61 is for pilots and instructors, and Part 63 covers flight engineers and navigators. Part 65 handles the certification for other crucial roles.
RICU.
Air traffic control tower operators, under Subpart B, aircraft dispatchers, under Subpart C, mechanics, under Subpart D, repairmen, under Subpart E, and parachute riggers under Subpart F.
Mechanics and repairmen key for our discussion.
Absolutely. And the chapter notes that mechanics are covered in much more detail later, in Chapter 15, but Part 65 is where the certification standards live. It highlights that it takes a whole certified team, not just pilots, to keep things running safely.
Definitely. Okay, then we circle back to the last of the big three, Part 91, General Operating and Flight Rules.
Yes, 14 CFR Part 91. We mentioned it's primarily operational, focusing on owners, operators, pilots. But as Figure 2.6 illustrated, it's deeply connected to recurrent airworthiness and maintenance.
So maintenance techs really need to know parts of Part 91, too.
They absolutely do. The chapter gives a couple of good examples. Section 91.207 deals with emergency locator transmitters, ELTs. It specifies how often the battery needs to be replaced, and it requires a specific logbook entry when that replacement happens. That's a direct maintenance task and documentation requirement originating in Part 91.
Okay, that's a clear link. Any others?
Another big one is just the general requirement embedded in Part 91 that an aircraft has to be approved for return to service with a proper maintenance entry after any maintenance before it can be operated. That directly involves the mechanic and the maintenance records.
Right, the plane can't fly until the paperwork is done correctly, according to Part 91 and Part 43.
Oh.
The chapter then introduces Part 119, which seems to set the stage for the different types of air carrier operation.
Exactly. 14 CFR Part 119, certification, air carriers, and commercial operators. Understanding this part is really helpful before you dive into Parts 121, 125, and 135, because Part 119 basically determines which of those operating rules applies to a given operation.
How does it determine that?
It uses 3 key criteria, as shown in Figure 2.8. First, is it private carriage or common carriage? Second, is it for hire or not for hire? And third, is the aircraft large or small?
Okay, let's break those down. Common versus private carriage.
Common carriage basically means you're holding out to the public, willing to transport anyone or anything from place to place for compensation. Advisory Circular 1/2012 lists those 4 elements. Holding out can be done through advertising, signs, or just establishing a reputation of serving all comers. Private carriage, on the other hand, is usually limited to specific long-term contracts with a few customers.
So common carriage is like a scheduled airline or an air taxi available to anyone. Private is more like a corporate flight department or flying for just 1 or 2 companies under contract.
That's a good way to think about it. Generally, common carriage falls under Part 121 or 135, while private carriage might operate under Part 91 or Part 125.
Okay. And for hire versus not for hire?
For hire is generally understood to mean you're receiving compensation that covers more than just the direct operating costs. There's usually an element of profit involved, directly or indirectly.
Right. And large versus small aircraft.
The dividing line there is typically a maximum certificated takeoff rate of 12,500 pounds. Over that is generally large, under is small, although there are nuances, especially with commuter category under Part 23.
Okay. And Part 119 doesn't apply to everything, right? There are exceptions.
Correct. Part 119 lists several operations it doesn't apply to. Things like student instruction, certain sightseeing flights near an airport, ferry flights, agricultural operations, banner towing, aerial survey, firefighting, pipeline patrol, and parachute jumps within 25 miles of the departure airport.
Good to know the boundaries. Okay, so with that Part 119 framework, we get into the specific operating rules, starting with Part 121.
Right. 14 CFR Part 121, operating requirements, domestic, flag, and supplemental operations. This is for the big players, the major scheduled airlines, the large cargo carriers.
On ones most people fly on.
Exactly. Part 119 requires these Part 121 operators to have specific management personnel, like a director of safety, director of ops, director of maintenance, chief pilot, chief inspector. It's a significant structure.
And for maintenance folks, what's key in Part 121?
It's a huge regulation, 28 subparts, 16 appendices. But for mechanics, Subpart J and Subpart L are particularly relevant. They both deal with maintenance, preventive maintenance, and alterations. Subpart J has special airworthiness requirements, and Subpart L requires the airline to have an detailed FAA-accepted operations manual that lays out their entire maintenance organization, procedures, personnel, inspection programs, and record-keeping system.
So the airline essentially develops its own comprehensive maintenance rulebook within the Part 121 framework.
That's a good way to put it. And there's also Section 121.1105, which specifically addresses requirements for aging aircraft inspections.
Okay. Then Part 125, what kind of operation is that?
14 CFR Part 125 covers operations using airplanes with 20 or more passenger seats, or a max payload capacity of 6,000 pounds or more, but not involving common carriage. So think large aircraft used in private or non-common carriage.
Like a large corporate flight department, maybe, or specialized transport?
Could be, yes. Operators under Part 125 need FAA-issued operations specifications, often called OPSPECs. These detail things like what operations they're authorized for, which specific aircraft they can use, approval of their maintenance manual provisions, weight and balance procedures, and potentially other items the FAA determines necessary.
And maintenance relevance.
Subpart E of Part 125 contains special airworthiness requirements, often related to mechanical devices on these larger, more complex aircraft.
Got it. And the third main operating part is Part 135.
Right. 14 CFR Part 135, operating requirements, commuter and on-demand operations. This covers two main areas: shorter distance scheduled commercial operations, often called commuter airlines, and non-scheduled operations like air taxis or charter flights, which are termed on-demand.
Okay, so smaller airlines and charter services. How does maintenance work under Part 135?
They also operate under an FAA-accepted operations manual, which includes their maintenance program. Section 135.411 is key here. It makes a distinction based on seating capacity.
Ah, okay. How so?
For aircraft with 9 or fewer passenger seats, the operator can generally use the manufacturer's recommended maintenance program and manual.
Simpler for smaller planes.
Right. But for aircraft with 10 or more passenger seats operating under Part 135, the air carrier has to develop its own comprehensive maintenance manual and get it approved by the FAA. The requirements for that manual are detailed in Section 135.427.
So more responsibility shifts to the operator for the larger aircraft in this category.
Exactly. There are also a bunch of other maintenance requirements in Sections 135.415 through 417 and 423 through 443. Sections 415 and 417 apply regardless of the seating capacity.
Okay. And there was a significant addition related to aging aircraft here, too.
Yes, very significant. In 2005, Section 135.422 was added, focusing on aging aircraft. It specifically targets multi-engine aircraft used in scheduled operations with 9 or fewer passenger seats, excluding operations solely within Alaska.
What does it require?
It prohibits operating these aircraft unless the FAA has done an aging aircraft inspection and a review of the maintenance records. The operator has to show they've adequately maintained age-sensitive parts. It specifies when the record reviews have to start based on the aircraft's age, sets repetitive inspection intervals, max 7 years, requires notifying the FAA 60 days before an inspection, and details what the records need to show years in service, airframe time, last inspection dates, life-limited part status, overhaul times for structural components, current inspection status, etc.
Wow, that's a very specific and detailed requirement for those smaller commuter-type operations as their aircraft get older.
It absolutely is a major step towards ensuring continued safety in that sector.
Okay. Moving away from operations, the chapter covers Part 145, repair stations.
14 CFR Part 145. This governs how repair stations, the facilities that maintain and alter aircraft and components, get certified and operate.
So the rules for the maintenance shops themselves.
Exactly. A key requirement is the repair station manual. Part 145 lists what must be in this manual. Things like their organizational chart, roster procedures, description of housing and facilities, how they update their capabilities list and training program, procedures for working away from their main base, procedures for working on air carrier aircraft, their record-keeping system, how they revise their own manual, and a system to control the manual's sections. It's basically their operational rulebook, approved by the FAAs.
Very comprehensive. Ensures consistency and quality control. Then Part 147, which is about the schools that train mechanics.
Right. 14 CFR Part 147, Aviation Maintenance Technician Schools. This sets the requirements for FAA-certificated AMT schools. It specifies curriculum hours, 1,150 for just airframe or just powerplant, 1,900 for both ratings because of the overlapping general subjects.
And it details the curriculum.
Yes. The appendices list the required subjects for general, airframe, and powerplant sections. These schools are obviously critical for producing qualified technicians.
Absolutely. The pipeline for new mechanics. Okay, then Part 183, about representatives of the administrator. What's that about?
14 CFR Part 183 explains the FAA's designee program. Basically, the FAA has limited resources and personnel, so they authorize qualified individuals in the private sector to act on their behalf for certain functions.
So they're not FAA employees?
Correct. They act for the FAA but aren't employed by the FAA. Common examples are aviation medical examiners, AMEs, for pilot medicals, pilot examiners for check rides, and designated mechanic examiners, DMEs, who give the practical tests for mechanic certificates.
Okay, I know about those. Are there others?
Yes, several important ones for maintenance and certification. Designated engineering representatives, DERs, can approve certain technical data. Designated manufacturing inspection representatives, DARs, perform conformity inspections, but usually only at their employer's facility. And designated airworthiness representatives, DRs, can perform various aircraft certification and inspection functions depending on their specific authorization. It's a way the FAA leverages industry expertise.
A force multiplier for the FAA.
Oh.
The chapter then makes a point of defining overhaul versus rebuilding. What's the difference there?
It's an important distinction. Overhaul generally means disassembling, cleaning, inspecting, repairing as needed, reassembling, and testing a component to the manufacturer's approved standards, which often means using approved service limits.
Okay, tested to approved service limits.
And rebuilt.
Rebuilt is a higher standard. It means the component has been disassembled, cleaned, inspected, repaired, or replaced as necessary, reassembled, and tested to the same tolerances and limits as a new item. It essentially implies restoration to a zero-time new condition, usually only done by the manufacturer or an agency approved by them.
Got it. Rebuilt like new. Overhaul meets service standards. Good distinction. All right, let's dive back into Part 43, specifically Section 43.3, which lists who can actually do the maintenance work.
Right. 14 CFR 43.3 lists 9 categories of persons, and remember, Part 1 defines person broadly, who are authorized to perform maintenance, preventive maintenance, rebuilding, and alterations.
Okay, who's on the list? Number 1, a certificated mechanic under Part 65. 2, a certificated repairman, also Part 65. 3, someone working under the supervision of a mechanic or repairman. 4, the holder of a repair station certificate, Part 145. 5, the holder of an air carrier certificate, like a Part 121 or 135 airline with an approved program.
So the professionals and the organizations, what about pilots?
Yes. Number 6 covers certain pilots, private, commercial, ATP, but not sport pilots who can perform preventive maintenance on an aircraft they own or operate, as long as it's not used in Part 121, 129, or 135 service. Sport pilots can do preventive maintenance on their own light sport aircraft.
Preventive maintenance only for pilots under specific conditions. Okay.
7 is interesting. Certain helicopter pilots operating under Part 135 in remote areas can do specific preventive maintenance tasks en route if authorized and following procedures. 8 allows Part 135 operators of smaller aircraft, 9 seats or less, to authorize their pilots to remove or install cabin seats, stretchers, oxygen bottles, etc., again with specific training and procedures.
And the 9th, oh wait, did I miss one? Mechanic, repairman, supervised person, repair station, air carrier, pilot preventive, remote heli pilot, Part 135 seat removal. I think that might be 8 listed in the summary, but the rule says 9 categories. We should double-check the text itself for the full list if needed, but those are the main ones discussed.
Good point. Always best to refer directly to the reg, but yes, those cover the primary authorized individuals and entities.
Okay, now, the chapter also helps distinguish between a repair and an alteration. How does it define that difference?
It's pretty straightforward conceptually. A repair brings something back to its previous or properly functioning condition. Replacing worn brake pads, fixing a dented fairing, swapping an engine with the same model, those are repairs.
Restoring it.
Right. An alteration changes the aircraft from its original type design or configuration. Adding winglets, installing a completely new avionics suite, changing the engine to a different model, those are alterations because they modify the approved design.
Repair returns, alteration changes. Got it. And then within repairs and alterations, we have the crucial distinction, major versus minor.
Yes, this is critical for documentation. A major action repair or alteration is one that, if done wrong, could significantly affect weight, balance, structural strength, performance, power plant operation, flight characteristics, or other airworthiness qualities. It's also something not done according to accepted practices or elementary operations.
That sounds potentially subjective. How do you know for sure?
It can be. Part 1 has definitions, and crucially, Part 43, Appendix A, provides lists of examples of what the FAA considers major alterations and major repairs for airframes, power plants, propellers, and appliances. That appendix is the go-to reference.
Okay, Appendix A clarifies. And the big deal is the documentation required, right?
Exactly. Minor repairs and alterations generally require acceptable data, things like manufacturer's manuals or guidance from sources like Advisory Circular AC 43.131B2B. The record for minor work is typically just a standard logbook entry under Section 43.9.
Okay, acceptable data, logbook entry for minor. What about major?
Major repairs and alterations require approved data. This is a higher standard. Approved data includes things like ADs, STCs, the aircraft's TCDS, data approved by a DER, or maybe FAA-approved manufacturer service bulletins.
Approved data needed for major actions. What if you have a major alteration idea, but there's no pre-existing approved data for it?
That's where a field approval comes in, using FAA Form 337. The technician fills out the form describing the proposed major repair or alteration, referencing the data they are using, which might be a mix of acceptable data they want approved for the specific case. They submit it to the local FSDO.
And the FSDO inspector reviews it.
Yes, an aviation safety inspector, ASI, reviews the data package. They might consult engineering specialists. If they approve it, they'll make an entry in Block 3 of the Form 337. This might state they only reviewed the data, or it might approve the alteration contingent on a conformity inspection. Either way, the work still needs to be inspected to ensure it conforms to the approved data.
Okay, so Form 337 is the pathway for getting FAA approval for major work when approved data isn't already available. Now, after the work is done, who can actually sign it off? Approve it for return to service. That's Section 43.7.
Right. 14 CFR 43.7 lists the persons authorized to approve an aircraft for return to service, RTS, after maintenance. There are 7 categories listed.
7 this time. Let's hear them.
1, a certificated mechanic holding the appropriate rating, or importantly, a mechanic holding an inspection authorization, IA, for certain inspections and major work. 2, a certified repair station, Part 145. 3, the manufacturer of the aircraft. 4, an air carrier operating under their approved program, Part 121, 135, etc.
Yeah.
5, a certificated private pilot, but only for preventive maintenance they performed on their own aircraft under the 43.3 limitations. 6, a repairman with an LSA maintenance rating, but only for light sport aircraft. And 7, a sport pilot, again, only for preventive maintenance they performed on their own LSA.
Interesting. What about the certificated repairman we mentioned earlier under 43.3? Can they approve RTS?
Good catch. No. A certificated repairman, non-LSA, can perform work within their specific authorization, but they cannot approve the aircraft for return to service. They make a maintenance record entry under 43.9 or 43.11 describing the work they did, but someone else with RTS authority needs to sign off the aircraft.
That's a critical distinction. Okay, let's talk about those maintenance record entries. Section 43.9 covers the basics, but not for inspections.
Correct. Section 43.9 details the content, form, and disposition of maintenance records for everything except the specific inspections covered under Parts 91, 125, and certain sections of 135. Those inspection entries are covered later in Section 43.11.
So 43.9 is for repairs, alterations, component replacements, servicing, that kind of stuff, and preventive maintenance too.
Yes, preventive maintenance entries fall under 43.9. So if a pilot does preventive maintenance, they need to make an entry according to this section.
What absolutely has to be in that entry, the what, when, who.
Exactly. You need 1, a description of the work performed. 2, the date the work was completed. 3, The name, signature, certificate number, and type of certificate held by the person approving the aircraft for return to service. And if the person who did the work is different, their name needs to be there too, though their signature isn't always required in the main RTS block.
And that signature only proves the specific work performed, right?
Correct. It certifies that the work described was done in accordance with applicable standards. Now, for major repairs and major alterations documented under 43.9, there's an extra requirement.
Form 337.
Yes, the entry needs to reference the completed FAA Form 337 by date, or if a certified repair station did a major repair, not alteration, they can use a signed work order and maintenance release instead, and the entry would reference that.
Okay. That covers documenting the work itself. What about parts, especially ones with life limits? That's section 43.NZR.
Right. 14 CFR 43.0, disposition of life-limited aircraft parts. This is crucial for safety. First, it defines life-limited Part 1 with a mandatory replacement limit, time, cycles, calendar, and life status, how much of that limit has been used up.
Okay. What does it require you to do with these parts?
It puts the responsibility squarely on the person removing a life-limited part to control it and track its status accurately. The goal is to prevent a part that's reached its limit from ever being reinstalled.
Makes sense. How do you do that?
The regulation lists acceptable methods, detailed record-keeping systems, physically tagging the part, using non-permanent marking, sometimes permanent marking, segregation, keeping them separate, mutilation if it's truly scrap, or another FAA-approved method.
And if the part changes hands?
Critically, the life status information must be transferred with the part, so the next person knows exactly how much life is left on it.
Total traceability for critical parts.
Oh, got it.
Now, section 43.11, you mentioned this covers the inspection entries that 43.9 excluded.
Exactly. Section 43.11 focuses only on the record entries for inspections performed under Part 91, like annuals, 100 hours, Part 125, and specific sections of Part 135, like 135.411A1 and 135.419. The requirements are similar to 43.9 what, when, who, but tailored specifically for documenting the results of an inspection.
Okay. So separate sections for documenting maintenance work versus inspection findings. The chapter then goes into how the work should actually be performed, the performance rules, starting with 43.13a.
Yes, this is fundamental. Section 43.13a essentially says you must use the methods, techniques, and practices laid out in the current manufacturer's maintenance manual or their instructions for continued airworthiness, ICA.
You have to follow the book.
You have to follow the book, or you can use other methods, techniques, and practices that are acceptable to the FAA administrator.
How do you know it's acceptable?
That's where things like advisory circulars come in. AC 43.131B and NEC 2B, for example, are titled Acceptable Methods, Techniques, and Practices. They provide guidance, especially if the manufacturer's data is lacking or doesn't cover a specific situation. But it's important to note, AC 43.13 generally applies to non-pressurized aircraft under 12,500 pounds.
Okay, so use the manufacturer's data first, or FAA accepted methods like those in AC 43.13 if appropriate. What else does 43.13a say?
It also stresses using the right tools, equipment, and test apparatus. You need the proper gear to do the job correctly following accepted industry practices. It even outlines a process if you need to use equivalent test equipment.
Proper tools are essential.
Absolutely. And there's a note for air carriers. Those operating under continuous airworthiness programs required by their op specs can use the maintenance manuals developed for their specific program, as those are already FAA accepted.
Right. Their customized, approved manuals take precedence. Okay, then Section 43.15 adds more performance rules, specifically for inspections.
Yes. 43.15 drills down on inspection specifics. For rotorcraft, it calls out certain items like main and tail rotor transmissions and drive shafts that must be inspected.
Critical components.
Definitely. For annual and 100-hour inspections, it mandates using a checklist. You can create your own or use the manufacturer's, but it must include the scope and detail outlined in Part 43, Appendix D.
Appendix D again, we'll get to that. Anything else for annuals 100 hours?
Yes, a specific engine performance test like checking power output, temperatures, pressures, or using engine monitoring data must be done as part of approving the aircraft for return to service after these inspections, regardless of the engine type.
Okay, gotta check the engine's health. What about progressive inspections?
For progressive inspections where you break the annual 100-hour into smaller, scheduled chunks, 43.15 requires that the program must start with a complete inspection of the whole aircraft first. It also defines routine inspection, usually visual, no disassembly, versus detailed inspection, thorough, requires disassembly, and overhaul is considered a detailed inspection.
Clear definitions there. The chapter then mentions Section 43.17 about Canadian maintenance personnel.
Right. Section 43.17 was significantly updated in 2005 because of the bilateral aviation safety agreement, the BASE, between the U.S. and Canada. It basically defines what Canadian aircraft maintenance engineers, AMEs, can do on U.S.-registered aircraft while they're in Canada, and similarly, what Canadian-approved maintenance organizations, AMOs, their version of repair stations, can do. It clarifies the cross-border maintenance permissions.
Good to know, especially for aircraft operating near the border. Okay, now let's tackle those Part 43 appendices. Appendix A is first.
Appendix A is super important. It provides lists that help clarify that major versus minor distinction we talked about. Paragraph A lists examples of major alterations broken down by airframe, powerplant, propeller, and appliance. Paragraph B does the same for major repairs, using the same categories.
So these lists are the primary reference for deciding if something is major.
They are the starting point, yes. And paragraph C is also key. It lists specific maintenance actions that are defined as preventative maintenance.
The stuff pilots can sometimes do.
Exactly. This list includes things like changing oil, replacing spark plugs, servicing landing gear struts, replacing bulbs provided they don't involve complex assembly. And as we discussed, private pilots, not sport pilots, owning operating aircraft not used in air carrier service can perform these tasks listed in Appendix AC.
Okay, Appendix A lists of major alterations, major repairs, and preventive maintenance. What about Appendix B?
Appendix B focuses on recording major repairs and major alterations. This is where FAA Form 337 comes in again. It states the form is typically used in duplicate. The original goes to the aircraft owner.
And the copy goes to the FAA Aircraft Registration Branch in Oklahoma City.
Right.
Where you mentioned that change from the local FSDO.
Correct. That change happened in 2005. Sending it directly to OKC. The appendix also mentions it's good practice for the mechanic or shop to keep a third copy.
Always good to have your own records. Is Form 337 always required for majors?
There's that exception for Part 145 certified repair stations for major repairs, not alterations. They can use their signed work order and maintenance release instead of Form 337, but they still have to send a copy of that work order release to the FAA in OKC.
Okay. Any other notes in Appendix B?
It mentions that Canadian AMOs performing major repair alterations on U.S. aircraft also send their documentation copy directly to OKC, and it reiterates that rule from Part 91 about needing a third copy of the Form 337 kept in the aircraft if extended range fuel tanks are installed in passenger or cargo compartments.
Specific rule for ferry tanks. Got it. Appendix D is next scope and detail of annual and 100-hour inspections.
Yes, this appendix lists all the items and areas that need to be inspected during an annual or 100-hour inspection. Key points here.
Okay.
1, the list of items is the same for both inspections. The only difference is who can perform them and approve the return to service. An annual must be done by a mechanic holding an inspection authorization, IA, as per Part 65. A 100-hour can be done by an A&P mechanic without an IA.
Same inspection, different sign-off authority. What else?
2, the aircraft and engine must be cleaned before the inspection starts. You can't inspect what you can't see properly. 3, the list isn't necessarily exhaustive. Any miscellaneous item not on the list but found during the inspection must also be inspected.
Common sense applies.
Right. And 4, it details 8 specific areas that require thorough inspection. Fuselage hull, cabin flight deck, engine nacelle, landing gear, wing center section, empennage the tail, propeller, and radio avionics.
So a very comprehensive checklist mandated by Appendix D, then Appendix E, the altimeter tests.
Yep, the Appendix E covers the altimeter system test and inspection. This ties back to Part 91, Section 91.411, which requires this test every 24 calendar months if you want to fly IFR in controlled airspace. People often call it the 411 test.
What does the test involve?
Appendix E lists the required tests: checking the static pressure system for leaks, testing the altimeter itself for accuracy, and testing the automatic pressure altitude reporting equipment, like the encoder for the transponder.
And you have to record it.
Yes, the appendix requires recording the test results in the aircraft logs and also marking the altimeter itself with the date of the test.
Okay, and Appendix F is similar, but for the transponder.
Exactly. Appendix F details the ATC transponder tests and inspections, often called the 413 test, referencing Part 91, Section 91.413, also required every 24 calendar months if the transponder is going to be used.
What tests are needed here?
These are quite complex electronic tests, usually requiring specialized bench or portable equipment. They check things like the radio reply frequency, signal suppression, receiver sensitivity, RF peak output power, and Mode S functionalities if equipped. And just like the altimeter test, proper maintenance record entries are required.
So Appendices E and F detail the nuts and bolts of those 24-month IFR system checks required by Part 91. That brings us nicely back to Part 91, specifically Subpart E, which is all about maintenance.
Right. Subpart E of Part 91 pulls together many of the owner-operator responsibilities related to maintenance. Section 91.401 just clarifies the applicability, noting that some sections don't apply to aircraft operated under the more structured maintenance programs of Parts 121, 125, 129, or 135.
Okay. Then 91.403 seems really fundamental.
It is. Section 91.403, titled General, places the primary responsibility for maintaining an aircraft in an airworthy condition squarely on the owner or operator.
It's their job to make sure it's safe.
Yes. This includes ensuring compliance with all ADs. The FAA actually sends AD notices to the registered owners. It also includes ensuring all maintenance is done according to Part 43, complying with manufacturers' manuals and ICAs, and adhering to any mandatory replacement times or inspection intervals from approved op specs, if applicable.
Owner-operator holds the ultimate responsibility. What about 91.405?
Section 91.405, Maintenance Required. This says the owner-operator must ensure the required inspections get done, ensure any discrepancies found are repaired per Part 43, and ensure proper maintenance record entries are made. It also includes that requirement to placard any inoperative instruments or equipment that are not required or have been deactivated.
So inspect it, fix what's broken, document it, and placard what's not working.
Oh, yeah.
91.47, operation after maintenance.
Yes. Section 91.407 reinforces that an aircraft can't be operated after maintenance unless it's been approved for return to service with that proper logbook entry we discussed under Part 43.
Right.
And importantly, if the maintenance performed might have appreciably changed the flight characteristics or substantially affected its operation in flight, a properly rated pilot must perform an operational check flight and log it before the aircraft carries passengers.
A test flight, basically. Is that always required after maintenance?
Not always. The rule allows for ground testing or inspection instead, if it can conclusively prove the maintenance didn't adversely affect flight characteristics. But if there's any doubt, a flight check is needed.
Okay, now 91.409 is a big one. Inspections.
Huge. Section 91.409 lays out the different inspection requirements. It starts with the baseline. Unless operating under certain specific conditions or programs, aircraft need an annual inspection.
Annual is the standard from those GA planes.
For most privately operated small aircraft, yes. Exceptions include aircraft under a special flight permit, experimental, light sport, or provisional certificates, or those maintained under an approved program for Part 125 or 135 operations, or certain Herben rotorcraft programs.
Okay. What about aircraft used for hire?
Aircraft used to carry persons or property for hire, including flight instruction for hire, need 100-hour inspections in addition to the annual. The annual inspection can substitute for a 100-hour, but a 100-hour cannot substitute for an annual because of the different sign-off requirements, IA needed for annual.
Right, and there's that 10-hour rule.
Yes, the 100-hour inspection interval can be exceeded by up to 10 hours if necessary to fly the aircraft to a place where the inspection can be done. But that extra time flown counts against the next 100-hour interval. So if you fly 105 hours, the next inspection is due in 95 hours.
You don't get free time. Okay. What about progressive inspections?
91.409 also covers progressive inspections. This is an alternative to the annual 100-hour cycle that an owner-operator can petition the FAA to use. It breaks the entire inspection scope from Appendix D into smaller routine tasks done more frequently throughout the year.
Who can do a progressive inspection?
It has to be supervised or conducted by a mechanic holding an IA or by a certified repair station or the aircraft manufacturer. It requires an FAA-approved schedule detailing what gets inspected when. There's also a 10-hour en route extension allowed for progressive inspection segments. And interestingly, the intervals can sometimes be adjusted based on service experience with FSDO approval. If you stop a progressive program, the aircraft immediately needs an annual or 100-hour.
So more flexibility, but requires more structure and approval. Are there other inspection programs?
Yes. 91.409 mentions others, like the continuous airworthiness inspection programs used by Part 121 and 135 carriers, an approved aircraft inspection program, AAIP, primarily for Part 135 operators, or programs based on manufacturer recommendations or developed by the owner and approved by the FSDO. Any changes need FSDO approval, and time cycles always carry over when switching programs.
Lots of options depending on the operation.
Yeah.
91.411 and 91.413 revisit the altimeter and transponder tests.
Right. These sections formally state the requirement for those 24-month tests we discussed under Appendices E and F. 91.411 covers the altimeter system, 411 tests, for IFR in controlled airspace. It details testing the static system, the altimeter, and the altitude reporting system. It also notes the static system needs testing after being opened, except for specific drains.
Who can do the 411 test?
The aircraft manufacturer, a properly rated repair station, or a certificated airframe mechanic. However, the mechanic is limited to inspecting testing the static pressure system. Calibrating or maintaining the actual instruments requires a repair station with the appropriate instrument rating per parts 65 and 145. TSO'd items are considered tested at manufacture. The test covers up to the maximum altitude the aircraft will be operated IFR in controlled airspace.
Okay, specific authorizations. And 91.413 for the transponder, 413 test.
Similar idea. It mandates the 24-month test per Part 43 Appendix F, plus the system test in Appendix E if the transponder has altitude reporting whenever the system is installed or maintained. Authorized personnel here are the manufacturer, a properly certificated repair station, or holders of continuous airworthiness maintenance programs under Part 121 or 135. No individual mechanic authorization listed for the full 413 test.
Got it. Now records again, section 91.417, maintenance records. What does the owner need to keep?
91.417 requires owners-operators to keep records of maintenance, preventive maintenance, rebuilding, and alterations. It specifically lists the permanent records that must be kept for the aircraft's entire operating life and transferred with it upon sale.
What's on that permanent list?
1. Total time in service, airframe, engines, props. 2. Current status of life-limited parts. 3. Time since last overhaul for items requiring overhaul on a time basis. 4. Current inspection status, type, date, time cycles since last inspection. 5. Current status of applicable ADs, method of compliance, AD number, revision date, time cycles when next action is due. 6. Copies of Form 337 for major alterations.
That's the core history of the aircraft right there. Do these records have to be carried on the plane?
Generally, no. The rule specifically says, except for one paragraph not detailed here, that carrying records on board isn't required, and it's often risky potential for loss or damage. Keeping them safely in an office with backups is usually recommended.
Good advice. And 91.419 says these records must be transferred upon sale.
Yes. Section 91.419 mandates the transfer. The records can be in plain language or coded, as long as the code is understandable. The buyer can let the seller keep the records physically, but the current owner is always responsible for making them available to the FAA or NTSB if requested.
Ownership transfer includes record transfer. Makes sense. Section 91.421 deals with rebuilt engines.
Yes. It explains that if an engine is rebuilt by the manufacturer or an approved agency, it can get a new maintenance record starting at 0 time, essentially wiping the slate clean of its previous operational history.
A first start for the engine log.
Right. But that new record must include a signed statement detailing the rebuild, confirming compliance with all applicable ADs, and confirming compliance with all applicable manufacturer service bulletins at the time of the rebuild.
Okay, specific documentation required for that 0 time status. Now, the chapter shifts back in time a bit, talking about the old civil air regulations and civil aeronautics manual CAMs. Why are these still relevant?
Because many aircrafts of flying today, especially those built from the 1940s through the early 1960s, were originally type certificated under the CARS, not the current AFR, 14 CFR. So if you're working on one of these older aircraft, the CARS might still be the official certification basis you need to refer to for certain maintenance or minor alteration questions.
So the rules the plane was born under still apply in some ways.
Exactly. The chapter mentions CR3, which was kind of the precursor to today's Part 23, covering normal, utility, acrobatic, and restricted category planes. Lots of Pipers, Cessnas like the 182, 195, 310 were certified under CR3.
And it notes that CAR can also mean Canadian aviation regulations, so be careful with context.
Right. It also mentions CAR 4A and 4B, which evolved to cover larger transport category aircraft before Part 25 existed.
Why is knowing the specific CR important?
Because the Type Certificate Data Sheet, TCDS, for each specific aircraft model will list its certification basis. You might find, for example, that a Cessna 140 land plane was certified under CR3, but the seaplane version of the same model fell under CR4A. or a Gulfstream G2 was CR4B, but the later GIIB, Model 1159A, was Part 25. You need the TCDS to know the specific rules that apply.
The TCDS is key for older aircraft. Okay. The chapter then briefly touches on suspected unapproved parts, or SUPs.
Yeah, just a quick warning about the dangers of installing parts that aren't FAA approved. It mentions 4 categories of SUPs and emphasizes the procedure. Segregate the part, quarantine it, contact the manufacturer if possible, and refer to AC 2129 for guidance. And there's an FAA website for reporting SUPs. Bottom line, don't install questionable parts.
Absolutely critical. Then it revisits advisory circulars, AC.
Right, just reinforcing that ACs are FAA guidance recommended methods, best practices, explanations, but they aren't regulations themselves unless specifically incorporated into a rule. The AC numbering system started in 1962, usually linked to the related FAR part number, subject area FAR part sequential number, revision letter like AC 43.131B.
Helpful guidance, but not law in themselves. Okay, let's dig deeper into airworthiness directives, ADs. We know they're mandatory, but how do they come about?
The chapter outlines 3 main pathways. The most common is a Notice of Proposed Rulemaking, NPRM, where the FAA proposes the AD, collects public comments, and then issues a final rule AD.
Standard rulemaking. What are the others?
Sometimes, if safety requires faster action, the FAA issues a final rule with requests for comments. They find that the usual notice period is impractical, often if compliance is needed in less than 60 days, so they issue the rule but still allow comments afterward.
Okay, faster, but still seeks input.
And the third type is an emergency AD. This is for urgent situations requiring immediate correction. The FAA tries to give actual notice to affected owners-operators as quickly as possible and then follows up by publishing the identical AD in the Federal Register.
For critical, immediate risks, what information is typically in an AD?
Usually, a description of the unsafe condition, the specific products affected, make, model, serial numbers, the required action or limitations, the effective date, the compliance time, e.g. within X hours, Y cycles, or by Z date, FAA contact info, and procedures for requesting an alternative method of compliance. AMOC.
AMOC.
Yes, if an owner-operator thinks they have a different way to fix the unsafe condition that provides an equivalent level of safety, they can formally request FAA approval for that alternative method.
Okay. And ADs have their own numbering system, too.
Yes, a 3-part number indicating the year, the biweekly period of issuance, and a sequence number within that period. Finding the right AD involves searching by the specific aircraft, engine, propeller, or appliance affected. And remember, compliance is mandatory per part. 91.403.
Got it. What about special airworthiness information bulletins, SABs? Are they like ADs?
No, SAIBs are different. They are non-regulatory. The FAA uses them to share information, maybe alert people to potential issues, educate them on a topic, or make recommendations. They don't mandate any action. Figure 213 shows an example about Cessna seatbelt brackets informative, but not a required action like an AD.
Information, not regulation. Okay. The chapter then mentions aircraft specifications and type certificate data sheets, TCDSs. We touched on these.
Right. Aircraft specifications were the precursor to TCDSs for older aircraft, some even predating type certificates, pre-1938. They're no longer issued, but still technically in effect for those aircraft, unless converted to a TCDS.
And TCDS is a current standard.
Yes. The TCDS is the formal FAA description of the type design for an aircraft, engine, or propeller. It lists all the essential data and limitations established during type certification, operating speeds, weights, thrust limits, required equipment lists, placards, control surface movements, etc.
The official blueprint description.
Exactly. Conforming to the TCDS is the first part of being airworthy. An aircraft that matches its TCDS and is in condition for safe operation is eligible for an airworthiness certificate. Figure 217 shows a sample TCDS page.
Very important document. What about supplemental type certificates, STCs? How do they relate?
An STC is an FAA approval for a modification to an existing type certificated product. If you want to change an aircraft, engine, or propeller from its original TCDS-approved design, like installing a different engine or new avionics not originally offered, you often need an STC.
So it modifies the original type certificate for a specific aircraft.
Precisely. The STC defines the change, how it affects the type design, which serial numbers it applies to, and lists the specific regulations the change was shown to comply with. That last part is helpful if you plan further mods later.
And owning the STC paperwork gives you the right to do the mod.
Not necessarily. The STC document itself, plus the underlying approved data, drawings, instructions, belongs to the STC holder. You usually need their permission or a license to use that data to perform the modification legally. STCs have their own numbering system too.
Good point about data rights. Okay, the chapter also mentions FAA handbooks and manuals and non-FAA documents.
Yeah, just pointing out resources like the FAA handbooks, like the one this chapter is from, which are great learning tools, and things like the Air Transport Association, ATA iSpec 2200 standard.
What's the ATA spec?
It's a widely used standard, especially for large aircraft, that standardizes how maintenance information is organized in manuals. It uses a chapter number system, like Chapter 72 for engine, Chapter 32 for landing gear, that's consistent across different aircraft types. Makes it easier for mechanics working on various fleets. Figure 219 shows examples.
Standardization helps. And manufacturers' maintenance manuals.
Absolutely critical. The Aircraft Maintenance Manual, AMM, covers the whole aircraft scheduled tasks, troubleshooting, repairs. Then you often have component maintenance manuals, CMMs, for specific parts like avionics or engines, detailing bench testing, overhaul procedures, disassembly, cleaning, inspection, repair, reassembly testing. If you use a CMM, you need to reference it in the logbook entry.
And the Structural Repair Manual, SRM.
The SRM provides detailed info for evaluating and repairing structural damage allowables, repair schemes, alignment checks, often separate for large aircraft, sometimes part of the AMM for smaller ones.
Okay, lots of manuals involved. Let's talk forms. Airworthiness certificates first, standard versus special.
Right. The standard airworthiness certificate, FAA Form 8100 TAC 2 is the main one, issued to type certificated aircraft in categories like normal, utility, acrobatic, commuter, transport, balloons, etc. Figure 220. It signifies the aircraft met its TCDS and was safe when issued.
And special airworthiness certificates.
Those are on FAA Form 8130-7, Figure 221, and are for aircraft in other categories like primary, restricted, limited, light sport, experimental. They often come with operating limitations. AC 2112 guides the application process, Form 8136.
Different certs for different categories. The chapter also shows FAA project numbering for TCs and STCs.
Yeah, Figure 215 shows the coding system the FAA uses internally to track certification projects, codes for project type, the aircraft's certification office, ACO involved, and the product type. Just background info, really.
Okay. Aircraft registration, we use Form 8051.
Yes, FAA Form 8051 is the application. You can get it online. Needed for U.S.-owned based aircraft not registered elsewhere. Needs proof of ownership and a fee. The pink copy of the submitted application serves as temporary registration for 90 days when carried with the airworthiness cert.
And the actual registration certificate.
That's AC Form 8053, note the AC prefix. Part 91 requires either the pink slip application copy or the actual 8053 certificate to be on board. You can get replacements from the FAA Aircraft Registration Branch in OKC if needed.
Got it. Now let's revisit FAA Form 337, Major Repair and Alteration. This one seems really important for mechanics.
It is. AC 43.9-1 gives detailed instructions on filling it out. Figure 222 shows samples. Remember, it's used for documenting major repairs and major alterations, with that exception for Part 145 repair stations using work orders for major repairs.
Walk me through the form. What info is needed?
Okay, Item 1, aircraft info, make, model, serial, and number, address. Item 2, owner info. Item 3, for FAA, use only, this is where the ASI signs off a field approval. Item 4, unit identification info on the specific part being worked on, if applicable. Item 5, type check, repair, or alteration. Item 6, conformity statement the mechanic or agency certifies the work conforms to approved data. Item 7, approval for return to service signed by the IA or authorized repair station person. Item 8, description of work accomplished, this is on the back, detailing exactly what was done and critically referencing the approved data used, STC number, manual reference, AC paragraph, DER approval, field approval date, etc.
Very detailed. And distribution.
Original to the owner. Copy to the FAA and OKC within 48 hours of RTS. Good practice to keep another copy. And remember that third copy needed in the plane if ferry tanks are installed.
Okay, Form 337 demystified. The chapter then loops back to emphasize making proper maintenance record entries per 43.9 and 43.11 and record retention per 91.417.
Yes, just reinforcing that every maintenance action needs a record entry and highlighting again those permanent records listed in 91.417 that stay with the aircraft forever.
Total time, life-limited part status, overall times, inspection status, AD status, major alteration forms.
Got it. What about electronic records? Is paper still king?
The chapter acknowledges the big shift towards electronic record keeping. It started with simple tech-developed databases. Now there are sophisticated commercial systems. Paper is still acceptable, but electronic is becoming common.
What should techs look for in an electronic system? The chapter lists good questions to ask. Is it user-friendly? Does it handle weight and balance? Good search function? Networkable? How are updates handled? Storage capacity? Can it handle different aircraft types? Track parts? Export data? Forecast maintenance?
Lots to consider.
Yeah, no single system is perfect. The advice is continuous learning, seeing different systems at trade shows, IA renewals, etc.
Makes sense.
Okay.
Finally, the chapter ends with a dedicated section on light sport aircraft LSA maintenance. This is a newer category, right?
Relatively new, yes. Added in 2004. LSAs include gliders, airplanes, gyroplanes, powered parachutes, weight shift control, lighter than air. Two types: special LSA, SLSA, factory built to industry consensus standards, and experimental LSA, ELSA, often kit built.
And the maintenance rules are different.
Significantly. Instead of relying solely on FAA-approved manuals like traditional aircraft, LSAs often use industry consensus standards, particularly those developed by ASTM International. ASTM F248305 is the key standard practice for LSA maintenance and manuals.
ASTM standards, okay. What does that standard cover?
It defines qualification levels for LSA maintenance personnel and the required content structure for LSA maintenance manuals. It also defines key LSA maintenance terms like annual condition inspection, similar to an annual but specific to LSA, heavy maintenance, line maintenance, LSA repairman inspection, LSA repairman maintenance, and major minor repair alteration for LSAs. The 100-hour inspection applies similarly to LSAs used for hire.
And the LSA maintenance manual, AMM?
It follows the ASTM standard, including specs, inspection checklists, maintenance or repair overhaul info for the LSA, including the engine.
How is LSA maintenance categorized? Who can do what?
It's broken down. Line maintenance. Simple tasks like 100-hour annual condition inspections, servicing, replacing certain components per the manual, minor repair salts per manual. Minimum cert is often an LSA repairman inspection rating.
Basic stuff.
Heavy maintenance repairs alterations. More complex work like engine cylinder replacement, primary flight control work, landing gear work, major structural repairs alterations per manual instructions. This usually requires a certified A&P mechanic or an LSA repairman maintenance rating, often with task-specific training from the manufacturer.
More involved work needs higher qualifications. What about overhaul?
Overhaul, engines, carbs, instruments, etc., can generally only be done by the manufacturer or an entity they authorize, using a specific overhaul manual.
And major repairs alterations on LSAs. Do they need a Form 337?
No, Form 337 is not required for LSAs. Instead, the work must be evaluated against the ASTM standards. The manufacturer or an approved entity provides written instructions, specifies the required certification level, required testing, and provides an affidavit attesting the aircraft still complies with ASTM standards after the work. It all gets documented in the LSA records as defined by the manufacturer.
So a different documentation path, relying on manufacturer instructions and ASTM compliance. What about training for these heavy tasks?
That task-specific training mentioned is the manufacturer's responsibility to define and provide. It's not FAA-approved training in the traditional sense.
Manufacturer-driven standards and training. What about ADs for LSAs?
LSAs don't get FAA ADs in the same way. Instead, the original manufacturer issues safety directives. If the LSA uses an FAA-type certificated component, like some engines, an FAA AD might apply to that component, requiring a safety directive. These directives typically list tools, parts, maintenance type, required cert level, detailed instructions, and inspection test methods.
Manufacturer safety directives instead of FAA ADs.
Got it. Wow. Okay, that was an incredibly detailed journey through just one chapter. It really drives home how extensive and interconnected all these aviation regulations are. You definitely get a sense of the sheer amount of thought and detail that goes into keeping aviation safe.
Absolutely. It's a complex web, but it's built layer by layer over decades of experience. And like we saw, even something as fundamental as defining airworthy only got formally locked down in the regs relatively recently in Part 3. Yeah, that was surprising. And the dual meaning of CARAR civil air regulations versus Canadian aviation regulations is a good reminder to always check context. It shows how even the language has evolved.
It really does. Understanding this regulatory foundation isn't just about knowing rules. It's about understanding the system that ensures safety from design through operation and maintenance. It's crucial knowledge.
Absolutely. So thinking about everything we've covered, this whole evolution of rules from the CARARs to 14 CFR, the addition of things like LSA rules and aging aircraft programs, it makes you wonder, what's next? What future changes or focuses might we see in aviation maintenance regulations as technology like, say, electric propulsion or advanced AI becomes more common? Definitely something to keep thinking about.
That's a great question to ponder. The regulations will have to continue evolving, no doubt about it.
Well, thank you for walking us through this incredibly dense but essential chapter. I certainly feel like I have a much clearer picture now.
My pleasure. It was a deep dive, but hopefully a valuable one.